All right, moving on to 5.3. It says, yesterday we looked at the special properties of parallelograms. What are these four special properties? Well, by definition, you already know both opposite sides are parallel, and then we learned that both opposite sides had to be congruent, both opposite angles had to be congruent, all consecutive angles had to be supplementary, and the diagonals bisect one another. Says Kara says that rectangles, rhombi, and squares have that share all the same properties that we learned yesterday for a parallelogram. Is she correct? Explain why or why not. The answer is yes, because all of those figures are parallelograms, so they must have all of those characteristics. Just like all mammals, I know that they have the platypus, but if you're a mammal, let's say a human is a mammal, so a human is going to have those characteristics that we found out that a mammal has. It's going to have more characteristics, but like special characteristics, but it will have all those. So yes, she is correct. Since they're all parallelograms, they have to have the same properties, just like a lab has the characteristic of a dog, mammal, and animal. What makes rhombi different than rectangles? Well, a rhombi must have all congruent sides by definition, and rectangles must have all right angles by definition. Look at the examples of the rectangle and the rhombus. Identify additional properties that the figure appears to have that are strictly parallelograms do not have. Look at the diagonals is the main thing. Well, for a rectangle, it looks like the diagonals are the same exact length. That does not seem to be true for rhombi though. It looks like you have one short diagonal and one longer one. So for a rectangle, you could say diagonals are congruent. For a rhombus, you have those diagonals are perpendicular, it looks like, and it also looks like they cut the angles in half. So those would be two characteristics that a rhombus has that it does not look like a rectangle has. Rectangle, it does not look like it is going to go over and be perpendicular diagonals, nor does it look like it's cutting the angles in half for this specific only rectangle non-square. Explain how you know that a square is going to have the properties listed above. Well, a square is both a rhombus and a rectangle, so it must have those properties as well. So now you know that a square is going to have all those properties a parallelogram had. It's going to have the diagonals being congruent because it is a rectangle, and it's going to have diagonals that are perpendicular because it's a rhombus, and diagonals bisect all angles because it is going to be a rhombus as well. Now, number 5. How can you justify that a triangle ACD and triangle BDC are congruent? You do not need to write a formal proof. I split the triangles up so that you could see it. Well, you have the right angles by definition of rectangle. The opposite sides must be congruent because it's a parallelogram, and then you have the reflexive property. With that, the two triangles must be congruent by CPCTC, SAS. And then it says, how can you use these triangles being congruent to say the diagonals have to be congruent? Well, by CPCTC, those diagonals have to be congruent as well. Now, the quick notes. A rhombus is going to have all the properties of parallelogram. It's also going to have all congruent sides by definition. It's also going to have diagonals that are perpendicular, and it's also going to have diagonals that bisect the angles. A rectangle will have all the properties of parallelogram, all right angles, and the diagonals are congruent. And a square is going to have all of them for parallelogram, all of the rhombi, and all of the rectangle properties. So it has a bunch of different properties that you can use. Now, using all this information, we're going to try to find out what these missing angles are. So angle 1 is going to be 90 minus the 23. That gets you 67. The other one is going to be, you could either use alternate interior angles to find out that it's 23 degrees, or you don't have to. And then once you have that, then you are going to be able to do 180 minus 23 minus 23. Let's see, why would that be? Oh, I know what it is. It's going to be because the angle over by the R that we said was 23 is going to be congruent to the other angle over by the P because of the base angles theorem. So 180 minus 23, that's going to give you that angle. Then when we're looking at number 2, which is a square, not only is that going to be a right angle because the square is a rectangle, but it's also a rhombus, so that angle is cut in half, so it's got to be 45 and 45. And then we also know the diagonals are perpendicular, so angle 4 has got to be 90 degrees. And the next one is strictly a rhombus. It is not being pushed to being a square. So you know that the diagonals are going to be perpendicular. So you have that 90 degrees, the 62 degrees, and then you could find out what's left over. And that angle is going to be 28 degrees. And if that's 28, then the alternate interior angle down by where 8 is also going to be 28 degrees. Number 2 says ABC is a rectangle if DW is 6 and BC is 11, find the other ones. Okay, so when you're looking at this, what you could do is you could go over and do the Pythagorean theorem, because if it's a rectangle, it has that right angle, and since it's a right angle, it's a right triangle, and you would use the Pythagorean theorem to get those parts that we did not know yet. Okay, next, number 3, look at the diagram below. How do we know that all sides are congruent on the rhombus? It's definition of rhombus, that's why. How do you know that AB is congruent to BC? AB is congruent to BC. Well, that would be because diagonals bisect one another for all parallelograms, so that's got to be true for a rhombus. What else do we have on the top left and top right of triangle? We have the reflexive property. So we have MB being congruent to MB. How do you know the triangle AMB and triangle CMB are congruent? Well, that'd be SSS. And now that you know that those triangles are congruent by SSS, those two angles must be congruent by CPCTC. And also, we know that those two angles by where the diagonals intersect, they have to be congruent, but they're also linear pairs. They add to be 180. And the only way they could be adding to 180 and be congruent would be if they were each 90 degrees. Now in here, it says circle all the figures that must have the following property. So a diagonal bisects both angles. That's true for a rhombus, and anything that is rhombus, a square is a rhombus. Diagonals bisect one another. That's true for a parallelogram. You don't even have to think about all the rest because they're all parallelograms, so you can circle them. Diagonals are congruent. That is going to be true for a rectangle and any other figure that falls in that is also a rectangle, which a square is a rectangle. So it's going to be a rectangle square. Both opposite sides are congruent. That's true for a parallelogram, so all parallelograms will have that property. Diagonals are perpendicular, that's a rhombus, and a square is a rhombus, so it would have it as well. Has a right angle, that's going to be a rectangle, and a square is a rectangle, so it's also going to be circled. Drawing diagonals results in two pairs of congruent triangles. If you went over and tried this out, you would find out that it works for a parallelogram, and if it works for a parallelogram, then it works for all of the parallelograms. And has congruent sides. Has all congruent sides. I definitely circled a bunch of stuff that wasn't supposed to be circled. So that was supposed to only be rhombus and square. I need to go back and fix my key. It's not going to be parallelogram and rectangle. That's what happens when I go too quick. So that wouldn't be rhombus and square. Next, complete the following proof to show that diagonals bisect. Ignore that. I think I changed it. I was going to make a proof, and then I decided just to have you guys go over and figure out what these angles were. All of the angles that we got here can be justified if you go back. They're all the same figures. I just changed the angle. So if you want to know how I got those numbers, just go back to the check your understanding, and it'll be the same justifications for all those different parts. The next one says, given the following, determine the length of AB for the following rectangles. Explain how you were able to get AB given the following. Well, I know how to get CD, just the distance formula. And if I know CD, then I know AB because it's a rectangle and the diagonals have to be congruent. So when I found out one being 10, the other had to be 10 as well. Rhombus ABCD has diagonal AC on the line y equals negative 2/3 x plus 5 with a restricted domain. What is the slope of BD? That's the other diagonal. Well, you know the diagonals are perpendicular, so if one is negative 2/3, the other one has to be the opposite reciprocal, which is 3/2. And the last one, come up with a mathematically backed argument why AM must be congruent to MB, which is congruent to CM, which is congruent to MD. Answers can vary, but you should probably say something about the diagonals being congruent on a rectangle, and they also bisect one another on a rectangle because it's a parallelogram. So if they're congruent and they cut each other in half, you're going to end up with 4 congruent parts. All right, hopefully that made sense. Thanks for watching.